In this video, we will cover permutations and combinations. Both permutations and combinations are ways of counting how many ways I can choose a certain number of objects from a certain number of possibilities. Talking about permutations, I'm figuring out how many ways I can select R objects from N possibilities and arrange them in order. The formula to calculate a permutation is given here on our screen. We don't need to use this formula as we have a calculator that can compute these permutations for us. But let's take a look at it in action with an example. Suppose we have 6 people and we want to find the number of ways to choose 3 of those 6 people and arrange them in order. How many different ways could I order the 3 people? The permutation formula takes into account how many different groups of 3 people I could choose out of the 6, and it also counts the different ways I could order those 3 people. To do a permutation, the notation is usually the n value, which is how many objects I'm choosing from, 6, with a capital P for permutation, and then the R value, which is how many objects I'm choosing out of the 6. In the formula, we see this exclamation point, which in math is a factorial symbol. It's a shorthand notation of writing a multiplication. When I say n factorial, or in this case 6 factorial, what it means is to take the number 6 and multiply it by every whole number all the way down to the number 1. So 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. I want to divide by n minus r factorial, 6 minus 3, which would give me a 3 factorial, or 3 times 2 times 1. Completing this calculation, I would get 120 permutations. Again, this takes into account all the different groups of 3 people I could choose out of the 6. But once I have each group of 3 people, I also count different orderings I can put them in. The other formula we want to take a look at is the combination formula. The combination formula does a similar action. It counts the number of ways I can choose R objects from N possibilities. But in a combination, once I have chosen those R objects, I don't care what order they're in. I only care how many unique groups I could choose. So let's take a look at an example for a combination formula. This example asks us, from our 8 friends, we can only invite 5 over for dinner. How many different groups of 5 people can we choose from our 8 friends? So I had to do a little critical thinking about whether to use a permutation formula or a combination formula for this example. I chose to use a combination formula because when selecting my group of 5 friends that I want to invite over for dinner, I don't really care what order they're in once I've chosen them. I really just want to know how many different unique groups of 5 I could choose. So this would be a situation to use the combination formula. Again, this formula is a little complicated and a little tedious to do by hand, but I can use a calculator to compute them. There are videos showing you how to calculate permutations and combinations using Scientific Calculator or Graphing Calculator, posted on the website. To do one example by hand, I would want to take the 8 factorial, because I'm choosing from 8 friends, and divide it by n minus r factorial, that's 8 minus 5. R is 5 because I'm selecting 5 people out of the 8. But I also multiply by r factorial in the denominator as well. If I expanded out my calculations by hand, you can see here I would multiply every number from 8 down to 1 in the numerator. I would do 3 factorial, which is 3 times 2 times 1. and also multiply that by 5 factorial, which is 5 times 4 times 3 times 2 times 1. This would result in an answer of 56. There are 56 unique groups of 5 people that I could choose. For every unique group, I do not care what order I have chosen them in. I am only counting each unique group as one combination. Let's sort of compare the difference between the two formulas. Let's say I had the letters A, B, and C, and I wanted to select 2 of those 3 letters. The first question is, how many combinations are there? Well, my n value in this problem would be 3 because I'm choosing from 3 letters, and my r value would be 2. And if I do a combination of n is 3, r is 2, I get an answer of 3. So what are those 3 combinations? Well, they would be A and B, A and C, and B and C. If I asked you how many permutations were there, using the permutation formula, again with an n value of 3 and an r value of 2, I would end up with an answer of 6. So what's the difference? Well, my 6 permutations include the 3 combinations A, B, A, C, and B, C. But when I consider permutations, the order I have arranged them in also matters. So the other 3 permutations that aren't combinations would be BA, CA, and CB. You can see here that AB and BA I have counted as 2 separate permutations, but it only counts as 1 combination. When I have a problem where the different orderings of the same items are to be counted separately, I would want to use my permutation formula. And when the different orderings of the same items don't matter, I would want to use the combination formula.